This next section is going to be on hyperbolas. We're going to want to write a hyperbola in standard form. We're also going to want to understand the pieces of hyperbola, and there's a lot of them. We'll want to graph them, and then in the second video we'll go ahead and write the equation of hyperbola from a general second degree form to a standard form. So let's go ahead and see what we already know about hyperbolas. Hyperbolas do look something like this. There's asymptotes here that the hyperbola kind of approaches, not kind of, but does approach. A hyperbola has a center, which would be right where those asymptotes intersect, and a hyperbola has a focus, just like the last shape that we worked with, the ellipse. Now, hyperbola could also be lying on its side as well, which we'll see in the next part when we analyze it, and the same qualities are maintained with the center and foci. Now, one last thing you should know is that hyperbola does have a major vertex, again, just like an ellipse, except that the vertices, though, are only going to be for a major one, and there's no minor vertices in an ellipse. I'm sorry, there's no minor vertices in a hyperbola. Okay, let's dive in and see what we have. Your center, here's your equations for a horizontal and a vertical. Your center is going to be HK. It's always HK. A is going to be the distance from the center to the major vertices. B is the distance from the center to minor vertices, but again, we don't really say that they have minor vertices, that hyperbolas have minor vertices. C is going to be the distance from the center to the foci, and what's nice about it is it's our Pythagorean theorem, so that should be helpful and one less thing that we have to remember. Let me draw you a picture of what's going on here. Notice the equations. If x comes first, we're horizontal. If y comes first, we're going to be in a vertical direction. But the h's and the k's will always be the same. The center will always be h and k. Notice also that it doesn't matter whether x or y comes first. A squared will always be first and b squared will always be second. Notice also that the hyperbola has a minus sign in between the two for the fractions. And finally, notice that our hyperbola's equations in standard form will always be equal to 1, just like an ellipse. So how does this differ from an ellipse, this equation? The equation of an ellipse was x minus h quantity squared over a squared. And you don't need to write this down for right now. Plus y minus k quantity squared over b squared equals 1. They look exactly the same. The only difference is the plus sign. So that is going to be one key for you on how to distinguish whether or not you have an hyperbola or an ellipse in standard form. Here's what happens with the ellipse. You start off with a center. That center is h comma k. I'm sorry, here's what happens with hyperbola. I keep saying ellipses because I really like ellipses. I don't know why. I should get an elliptical. Yeah, hyperbola has a center h comma k. And if I'm on a horizontal transverse axis, I go over some amount a, however much that a value is, in the left and the right direction. I also go an amount b, up and down, but that b value could be smaller, it could be bigger, we don't really know. We have to look at the equation for that. But I go up and down a b value from the center. I go over left and right from the center for my a value. Now, what that gets me is it gets me a box. And if I connect the edges here, I get a nice little box. If I connect the diagonals of that box, so if I actually form the diagonals of the box, I end up getting these asymptotes. So again, the black dashed lines are the asymptotes here. Now, please keep in mind, when we first started off, these were our major vertices. So the shape of our hyperbola starts at our major vertex, and they follow the asymptotes forever and ever. Finally, you do have foci here, as if this wasn't enough, and the foci is going to be from the center all the way to a little bit inside the hyperbola in the left and the right direction, because we are horizontal. Literally, it's the same thing, but vertical for the other part. So I'll do this very quickly. We start off with the center, HK. This time we would go up A. Instead of left and right A, we would go up and down A. We would also go to the left and to the right B, however much B is. We can draw a box with that given information. And we can inform the diagonals of that box. Those are our asymptotes. When we drew the A value, that gave us a major vertex on top and bottom, because we are vertical hyperbola here. And that allows us to sketch our hyperbola, the hyperbola following the asymptote and starting again at the major vertex. And the foci is going to be that distance from the center to a little bit past the major vertex. And that's what we're working with here. If you're scared, I am too. Let's go ahead and go. Our center. Let's dive right into it. We have 2, -1 for the center, looking at opposite signs for what's inside the parentheses. My A value is going to be 3, because A squared always comes first, and B is going to be 8, the square root of 64, and again, I'm following this equation here. I am noticing that the x comes first, and because the x comes first, the hyperbola is lying on its side. So let me go on a graph for the information that we have now. I have 2, -1. My A value is 3, so I'm going to go to the left 3 to 5, -1, and that's one of my major vertices. I'm going to go to the left 3, and that's going to be at -1, -1. Okay, so that takes care of the first part. I got my major vertices and I got my center. I'm going to put my center in red to distinguish it from the major vertices. And let's go and take care of that B value. Now the B value says I have to add 8 to the Y value. So let's add 8 to the Y value of the center, and that's going to put me at 2, 7. It's also going to put me at, if I subtract 8 from the Y value, at 2, -9. These blue values are going to be the endpoints of the box. I'll sketch my box. And if I sketch the diagonals of that box, those are going to be my asymptotes. Now, next. I'm just going to make the major vertices a little bit bigger. Since I am looking at a horizontal hyperbola, I know my hyperbola needs to look like this, and it's following the asymptotes. That's what my hyperbola looks like, and that takes care of the graph part of this. Now I need to just take care of the asymptotes and the foci. To get the foci, because that's the easier one, I'm going to do a squared plus b squared equals c squared. A squared is 9, b squared is 64, and I'm going to solve for c squared. It looks like c is going to be plus and minus the square root of 73. That means I'm going from my center in a horizontal direction, which means I'm adding 2 here. So I'm going to do 2 plus the square root of 73. The y value stays the same, -1. I'm also going to have 2 minus the square root of 73 and -1. The last part is hyperbolas. I'm sorry, the last part is the asymptotes. I need to find the equation of this asymptote here. Now this asymptote, I'm going to use this equation of a line. I'll use this equation here in purple. And it's going to be y is equal to m times x minus x1 plus y1. This is called point slope, and you've seen this before. I'm going to change this with the points that we have, and I have a center, hk. So I'll have y is equal to, and I'll fill this part in, x minus h plus k. The h value we had earlier, that's going to be the x-coordinate, which is going to be 2. So I'll have x minus 2. The k value we got earlier, that's going to be a plus -1 or a -1. Now, I need to find the slope. The slope of this curve, or I'm sorry, the slope of this line, I went up 8 because that was my b value, and over 3. So my slope here is going to be 8 over 3. Notice I do have two vertical asymptotes though. I'm sorry, I do have two slant asymptotes, one going in a positive direction, one going in a negative direction. So I can write this all together as y equals plus or minus 8 over 3, x minus 2, minus 1. I know that's a lot. I hope you're still alive. Let's go on and try the last one. You're going to try this on your own. Pause the video, resume when you're ready to go. Hopefully you saw that we did have a vertical transverse axis. Again, how did I know that? Because y came first. The center was 5, negative 3, because the 5 is, the h always goes with the x, the k always goes with the y. So our center is 5, negative 3. My a and b values are the same, and I did a Pythagorean theorem to get root 50 for my c value. I started at 5, negative 3, and since I am going in the y direction this time, I went up 5 from 5, negative 3, and that's how I got 5, 2, and 5, negative 8. The x values stayed the same because the y values are changing. Now, if I continue on, my other values, if I go to the left and to the right 5, so if I go left 5, that's going to get me there, and if I go to the right 5, I'm going to be at 0, negative 3. I'm sorry, I shouldn't be writing this down yet because it doesn't ask for it. But I'll be at 0, negative 3, and 10, comma, negative 3. I'll draw my box. And you're thinking, oh, what a pretty box, Mr. Lakin. I know, I tried. Here's your diagonals, or your asymptotes. The asymptotes will intersect at the center. And I'm just going to highlight again where my major vertices were. They were at 5, negative, they were at 5, 2, and 5, negative 8. Now, my asymptotes are a little bit off here, so my picture is not going to look as good as yours probably, which is 99% always going to be true. And when I draw the hyperbolas are going to be approaching the asymptotes. To find the foci, again, since I am going in a vertical direction, I'm going to need to add to the y value of the center, and I have my c value here. So the foci, or one focus, is going to be going up root 50, which means that the coordinate of it will be the same x-coordinate, 5, same x-coordinate as the center, 5, comma, negative 3 plus root 50, and 5, comma, negative 3 minus root 50. Finally, for the asymptotes, I'm going to use that same equation that I developed the last time. Y is equal to, I'll fill in my slope in a second, x minus 5 minus 3, because this is my h and k coordinate. And then for the slope, it looks like I went up 5 and I went over 5. That's going to give me a value of 1. I'm going to have a plus 1 here. To get both asymptotes, I'm going to have y is equal to plus and minus 1, x minus 5 minus 3. Alright guys, that was a lot. In the last video, we'll go ahead and write the equations in standard form for hyperbolas from a general equation. Thank you.